I've got voltage drop in this brand new system, and I'm going to try to track it down.
Voltage drop is generally caused by something in an electrical circuit creating resistance and preventing the free flow of current through the circuit. But let's back up.
So I experienced something I've never personally experienced before when dealing with electrical issues. I was shocked. Not literally, but emotionally, after installing my new lithium battery bank, to find that as I turned the electrical instruments on, the load seemed to be too much for the bank to handle. Most, if not all, the instruments would not come on, and the analog battery monitor showed a large drop in voltage as the load was added. The amperage being drawn by this load was only 5 to 10 amps, which is not a lot, so something was clearly wrong. I will share what I learned from solving this issue so you too might benefit. Hi, I'm Sailor Eric. If you're interested in sailing or boat maintenance, you have come to the right channel. I just finished rewiring my entire battery circuit, which included crimping lugs to wires, in addition to introducing new terminals, bus bars, and switches to the circuit. There must be a connection point I installed that is faulty somewhere.
This is a 12-volt direct current system. Voltage is a measure of pressure in an electrical system, while amps is a measure of the rate of current flow. Voltage dropping across the circuit means the pressure needed to power a device is lower than desired at the point the device is drawing from. In a properly wired system, voltage drop should not exceed 5%. Practically, that means that if I have a new lithium battery bank that's charged up to 13.78 volts, the devices I power on should not receive less than 13.09 volts of pressure. 5% is considered acceptable because it is understood that every wire, every connection point, every fuse, every bus bar, every switch is going to introduce small amounts of resistance into the circuit. The combined amount of resistance is expected to yield no more than a 5% drop of voltage.
Here's what I did to identify where in my circuit the voltage drop was coming from.
My voltage drop was caused by excessive resistance somewhere in the system. In plumbing terms, this would be like a blockage in a pipe. I connect a portable DC light fixture to the positive outgoing end of the battery bank fuse and the negative end to the outgoing negative bank terminal. The light bulb comes on. I then check the voltage on those two leads and see a reading of 13.74 volts. I then touch the leads against two battery terminals and find a reading of 13.78 volts. The difference between these two readings is 0.29%, which is an extremely small amount of voltage drop compared to the 5% tolerance. For funsies, I decided to quickly try to measure where the small voltage leak was coming from on the main battery circuit. On the negative side, I put one lead on the negative bus bar and moved the other lead to different points on the shunt and the outgoing terminal, and found 0 voltage reading in all cases, which means no voltage drop. On the positive circuit, I put one lead on the positive bus bar and the other lead on the outgoing part of the fuse and found 0.02 volts on the meter, which means there was a 0.02 voltage drop between those two connection points. This is the methodology you should use to find voltage drop in your system. When connecting the light bulb terminals further down the circuit, I found that the positive connection point just after the switch was drawing current and powering the light bulb despite being off. When I turned the switch on, this generated higher pressure and a brighter light, but not liking that off didn't really mean off.
I don't like that at all, and I have a feeling this switch is the cause of all my problems, so I think I'm going to replace that switch.
After connecting the new switch and turning it on, I took a voltage reading by connecting the same points where the light bulb was connected to and found a reading of 13.37 volts. 13.37 divided by 13.78, the voltage we found at the batteries, results in 97%, which means we have about a 3% voltage drop from the battery bank to this point in the circuit. That's not great, but it's acceptable and under 5%, and our instrument should now work. I would note at this point that I am using a relatively inexpensive multimeter, and probably the biggest difference in an inexpensive multimeter versus a high quality, more expensive multimeter is going to be the precision and consistency of the readings. I have less expensive test equipment, so I should calibrate and be willing to accept a higher range of variance and error. Now let's verify that the system works.
All right, just turn that on now. Holy shit. Stuff is turning on. So I'm going to turn on more stuff. So here goes the VHF. And that's coming on. I'm going to turn on my instruments. GPS, radar, instruments, autopilot will go out and we'll check. But this is the telltale. When I was testing this voltage here, look at how green I am there. I'm over 13 volts. All right, I got instruments. I'm pretty happy about that.
Here, the gauges are all working as they should during our sail to deliver Silver Heels to Monroe Harbor.
Coming from the realization about a month ago that the entire electrical system would have to be overhauled on a DIY basis to where the boat is at today feels darn good. The sailboat is more capable and self-sufficient today than it was a month ago for sure. I want to thank my subscribers. Your support means a lot and motivates me to create more videos. If you have stayed till the end of this video and enjoyed the content, please press that like button now. This action is free to you and it creates a higher probability that people like you will find my videos in their feed and be introduced. This is Sailor Eric. Thanks for watching.